Okay, so welcome to MSE 2114 week 3. We're going to look today at importing data and doing some data analysis and also exporting or resaving back into, say, an Excel file. So your homework this week you can find in the 2114 homework file. I also have it shown here in the lesson. So we're going to go over similar problem, but not this problem. So you'll have to adapt things to this problem as well as the practice. We'll go over some things that are kind of related to what you might need for this, but you are going to have to actually modify what's in here. So let's go ahead and take a look first at part one. This is going to be the importing and cleaning and analyzing and exporting your cell data. And then part two, we'll look at some related things relative to those practice problems. All right, so we're going to go ahead and we're going to import all of the packages that we need. That's kind of our first step always. So I'm going to go ahead and run that. So I've imported NumPy. You've seen that before. Importing pandas. This is a package we're going to use to bring in the Excel file in a sheet format so that we can analyze it and manipulate it easily. We're going to use matplotlib to make some plots, and we'll use this as plot so that plot will become our alias that we'll use for making those out of pyplot. And we're going to use this pathlib path command to help us with defining the paths to files. So we've got that run. All right, so how do you define file paths? So file paths sometimes can get a little well, there's multiple ways of doing it. I've picked one in this particular lesson that I'll try and stick with throughout. Between Windows and Mac, there are slightly different ways in which this can be done. The Windows likes to use the Windows uses, I think, the / command, and the Macs use the forward, and so there is that difference. And so what I've got here is a way using this path function so that it will convert the path into whatever machine you're using. So I have a Windows machine, so this is telling me that my path that I've defined here is a Windows path. If you're on a Mac, then this would be defined here as a Mac path. And so this should take care of the issue with what machine you're on. So basic idea is find your file, and you can do a properties, right click on your file to find its location in your machine if it's not obvious otherwise, and you can just kind of highlight and copy that. That'll give you the path to your file. And so what I can do then is I can go ahead and take that path and just paste it into this path command. So this is my path. I still have to define my file name, but that's my path. And for the Windows machine especially, since it uses these backslashes, and these backslashes have other uses, and so generally this is a problem. With the Macs, I think they use forward slashes, and actually this won't be an issue. With the backslash, though, you've got to use this R, and this, you've seen F strings before. Well, this is an R string, and this just means that this is a regular expression. To treat this text as a regular expression basically tells it to ignore these backslashes in terms of their other functions and just see them as text. And so we need to do that with the Windows machine. My other option is to put the path in this way using the forward slashes, and then I don't need to specify the R. And so on the Windows machine that I'm using, and I know many of you have, when you do a cut and paste, it's going to be the backslash. So I'm going to use this first option here because I don't have to do any changing. I'm just going to paste it right in. So I'm going to use this path 1. I'll go ahead. Actually, this one I'm not going to run because this is this isn't the final path I'm going to need. It's just an example for you. And then so then we would grab that, take that path, then we would take the file name. So we'll go ahead and define whatever the file name is that we want. And then we would go ahead and attach or append that file name to the path name. and using this / character. Okay. And then finally, our full path, if we wanted to see it, looks something like this. But notice the file is tacked on the end. So this is the way that we'll do it. So let me go ahead and let's go ahead and do that now. So I'm going to close this one up. Let's go ahead and do that. So my path here in this particular case, there it is. I've kind of just pasted it in. The file that I want to look at, and I'll put this up into Canvas so you can download it and play with it if it's not there already. Student credit hours, department numbers, and it's an Excel file. Okay. I'll combine my path and my file name, and then I need to read it in. And so this is where we use pandas. So we imported pandas as PD, right, as our shortcut. So we can just do PD dot and then read Excel. That's a function in pandas, and we just pass it the path. And I'm assign this to a variable called raw Excel, because this is my raw data, and then I'm going to take and manipulate it into a set that I'm going to use. And so I'm going to just display it here so we can see what it looks like. Okay, so the nice thing about pandas is that it takes your Excel file and imports it into what it calls a data frame. It's basically a sheet. It's a big table, and it allows you to access the table very nicely. The table has column names that we can use to access it, and it also has row indices that we can use to index a certain or to call out a certain row. And so this is a much nicer way of dealing with data in the form of tables. Right? So that's called a data frame. And so many times when people import and start using data that's pulled in from pandas, so I'm going to go over to cleaning the data, they use df a lot. You can call this anything you want. It's like I called the other one raw Excel. But if you're looking through codes, a lot of times you'll see this df, or you're looking through pandas help files, you'll see df. It just stands for data frame, and people just generally use that when they don't want to come up with another name for their file. So it's just kind of a convention. But that's all that is. Nothing special about it, but it comes from the fact that this is a data frame. All right, so what I'm going to do is I'm going to take this raw Excel data frame, and I'm going to now drop all of the columns and rows that consist only of NA values, this NaN. Okay, so when there's no defined quantity in the Excel file, Pandas imports it as NaN. Okay, not a number. And so I'm going to drop those. Now I have to be careful how I do this. I don't want to drop rows that have one NaN in it, because then it would get rid of my data. I want to drop rows that have this NaN for all columns. And so that's the all command here. So how all means if the entire column is NaN or the entire row is NaN, then go ahead and drop it. Now I guess my axis 0, this particular command right here, means to look at rows first, and then I'm going to do it again, and axis 1 is the columns, and then I'm going to look at all the columns. Okay, so this 0 row to row 4 here are going to get dropped. They're all NaNs. And these first couple of columns, column 3 will get dropped, and then these columns out here are going to get dropped. So I can just grab this data that's right in here. Just the other thing to point out, when we're dealing with data frames, and actually most things in Python, the first row and the first column are indexed as zeros. Okay, so let's just make sure we remember that. Okay, so I'm going to go ahead and do that. And so I create my data frame by removing rows, and then I take that data frame and then I drop the columns. All right, so this is what's left of my data. And you can see right now I'm at index 5 here for my rows, and my columns that I haven't actually named yet start at 4 to 9. Okay, next thing we're going to do is we're going to get rid of this row. Okay, so I don't need this row here. There's no real data in it. And next, actually, row 6 actually has my column headings. So I'm going to go ahead and drop row 5. And so we'll use the drop command. So just drop, and then the index for the row is 5. And so if I want to drop a row, all I got to do is tell it what row index it is. So there it is, it's 5. All right, and now I can go ahead and label my columns. And so what I'm going to do is set columns. So df, this data frame dot columns will actually give me a list of the column names. But here I'm actually taking it and setting them equal to, and I have to give it now the same number of labels as there are columns. And so I'm going to call them, as you can see down here, number of faculty, department, on campus, etc. And so I'm going to give myself column names. That'll get rid of these unnamed values. And so now I get this one. Well, I have column names, so I really don't need row 6 anymore. So let's go ahead and drop that index 6. Okay, so that's gone. And then notice that every time I'm doing this, it's still maintaining the original index values. It'd be nice at this point to now go back and reset the index after I drop this row so that I start over again at 0. And so that's what we're going to do. We're going to go ahead and reset the index. Drop equals true means to get rid of the old index and replace it. If I don't have drop equals true there, then this becomes a column in my sheet, and I just get a new index. So we want to replace it. And then I'm also going to do that fill NA command again. I'm sorry, we did drop NA. We're going to do fill NA now. So this is going to go through and find all of the not a number values, and it just says replace all of those with a 0. And so there it is. So there's my data. It's nice and clean. I've got column headers. I don't have any more of these not a number things floating around. I've got some zeros in their place. And I've reset my index. So those are the standard things that you would do typically when you call in a data set. All right, so now I got my clean data. Now I haven't actually been running this as I've been going, so I better do that, or I won't be able to show you the code below. So I'm just running these. Okay, so now I've got my data set. So let's go on to the next step, which would be the analysis. So I think what I'm going to do here is I think I'm going to go ahead and pause the video, and then we'll come back and we'll start here at analysis for part 2.